All right, everybody. So this comes from this kind of question today that I didn't know how to answer via text or email. So I thought I'd make a video. So I get a lot of questions about this, and a lot of people don't know about this part of VRV. But there is a line item in Service Checker that makes no sense to absolutely everybody. And so we're going to cover it. It's not in the service manual. I mean, there's a little bit, but it's very vague and very difficult to understand. So we're going to cover it really quickly. Demand stepping down control. What is demand stepping down control? Now, with Service Checker, we have the ability to actually measure current amp draw. That's the black line here. And what I can do is I'll take away all the mumbo jumbo that you don't need to see here. There we go. Okay. Demand stepping down control. This is where your VRV system is rated for an MOCP, right? Maximum overcurrent protection. Now, the unit knows what size maximum overcurrent protection it's rated for, and so it's going to do its best to protect itself from tripping the breaker. What does that look like? Well, a system under high demand and high load, whether the charge is off, whether it's overconnected, let's say it's running at full max speed, and the amps are climbing like they are here, right? We're at, let's go back up here really quickly. 39.2 amps, right? 39.2 amps, 39.2 amps, and then boom. What do we hit? 64.2. Well, the MOCP for this unit is 60 amps. So what does the system try to do? It says, hey, go into demand stepping down control. That's this little blue dot here. So if I take it away, add it, take it away, add it, right? This is the remix. Here we go. Okay, so actually I think I have that. Yeah. Oh, there we go. Anyways, so demand stepping down control. It is the VRV system protecting itself from tripping the breaker. That's right. It's a smart system. It understands where the actual current draw is on the system. Now, this doesn't mean that the compressor is bad. This could mean that your electrical connections are crap. This could mean that the breaker is about to fail. This could mean due to loose connections, the guy who put wire nuts in the outdoor unit, or where they like to just loop the wire under the lug nut, which you're not supposed to do. Right? NEC is very clear about what we should and shouldn't do. Just because an air conditioning guy never read it and hooked up the wires doesn't mean that it's okay. So that's demand stepping down control. And if I move on through the data, and you're not going to find this in every set of data, but for this one, we actually have it to discuss what we're talking about here. Again, here we go. Let's go to the amp draw here. 59.1 amps. It is not in step down control. However, when we go bloop and we go over that, 63.4, it turns on. And it stays on until the amp draw, even look here, we're at 60.8. It's still over 60. So until we actually go below 60, then it drops out. Well, what does it do for the system, Roman? It limits your compressor speed. It limits the top range of your compressor speed to say, hey, I can't increase compressor speed any higher safely without tripping the breaker. So what do? I keep it the same. It doesn't change, right? Here we go. It stays the same. See in the data? See how I prove that? I say one thing, and then I show you the exact same thing here. So it doesn't change. You can see where it blipped up and the amps got way too high, and then it brought it back down again. Again, it's going to maintain this until it gets below that amp draw, and then it will actually allow it to change speeds again. So again, demand stepping down control is the system protecting itself from overcurrent on the actual entire unit. That doesn't mean your compressors are overamping. That doesn't mean that your system has problems, although charge could be a factor in amp draw, right? Dirty condensing coils can increase the actual static load on the outdoor fan motors, which could increase the amp draw, right? Things we know that motors, when they're put beyond their operational limits, they pull higher current, which causes higher amps, which could cause the totality of this being over the MOCP. But again, demand step down control being on your service checker data means you need to evaluate why is it pulling such high amps, right? Again, this is demand step down control explained that you will not find in the service manual, nor will anybody really tell you from the factory side, because I'll be honest, I'm not sure if they even know it exists. This is what it's used for. This is what it's designed for. If you're not looking for that in your service checker data, again, you won't find it in every set of data, but when it's there, I would take a look at your actual total system amp draw and electrical usage to determine, okay, why won't it run on anymore? Why won't it ramp up anymore? Why can't I deliver the demand that the system needs? And again, this system that I'm looking at is undercharged. And because of that, compressors overheat. What happens when motors get hot? They pull higher current. And again, the total system running at full speed with everything on, trying to cool the space down or heat the space up, results in it limiting itself to keep the breaker from tripping. So there you go. Now you have it.